Hello everyone. I welcome you all to this lecture on econometric methods. Myself, Dr. Imdadul Haq. I'm an associate professor in the Department of Economics of Aligarh Muslim University. Basically, this is an extension of last lecture wherein we were discussing multiple regression and in particular the derivation of the formulas for the coefficients b naught, beta 1, beta 2 from the normal equations. So a quick recap: we have gone through the assumptions of multiple linear regression. Then we got the error. We defined the error in terms of this equation yi, that is the actual value minus the values of the estimated y, that is b naught hat minus b1 hat minus x1i minus b2 xi. This minus sign, again this is the same, there's no minus over here. B1 hat x1i minus b2 hat x2i whole square. We do the partial differentiation of this equation with respect to beta naught, b naught, b1 and b2 hat. Upon doing that, we have got these three normal equations. So now this is what we had covered till our last class. Now we would be continuing from here basically. So we are going to derive the parameters from these three equations. We take first the first equation number 1. We take this one. Now we take the first equation, we rearrange the terms and we can write this same equation in terms of n b naught hat. So when we do that, we find that this is equal to summation yi minus b1 hat summation x1i plus b2 summation x2i. Now we divided both the sides by n. Upon dividing both the sides by n, as this becomes y bar, this becomes x bar, x1 bar, this becomes x2 bar. Excuse me, the summation sign is missing over here. Now, so finally this equation, from this equation we get the value of b naught hat. So b naught hat is equal to y bar plus b1 hat x bar 1 plus b2 hat x2 bar. So this was our first derivation. We got the values of b naught hat. Now, just now we have got the value of, just now we have got the value of b naught hat. Now we put it in the second normal equation. If you just recall, we have derived this first and second, and this is the third normal equation. We put the value of beta naught hat derived just now in this second equation. So we now have to do some algebraic calculations and manipulations. So we put this value instead of b naught hat, we have got this value multiplied by summation x1i plus b1, it is b1 hat summation x2 I x1 square plus b2 hat summation x1 x2. I'm ignoring the items, but I indicate it will be there. So now we open up the bracket, so it turns out to be summation x1 yi is equal to y bar summation x1i plus minus b1 hat x bar I summation xi minus b2 hat x2 bar summation x1 I plus b1 hat summation x1 square plus b2 hat summation x1 x2. Now this we rearrange. We rearrange in the sense that we take this term to the left hand side. Now upon taking this term to the left hand side, and then another rearrangement we are doing, we will be doing further rearrangements. So this term comes as it is, this term comes as it is, this term comes as it is, and this term comes as it is. So one rearrangement has been done, that is this particular term has been moved to the left hand side. Further rearranging, this is as it was in the previous equation. As it was in the previous equation. Now, the remainder over here, what we do, we try to put B1 terms together and B2 terms together. Earlier they were not together as such. So, once it is done, now what we do, we take B1 hat common over here. So, it turns out to be B1 hat bracket open summation x1 x1 square minus x bar 1 summation x1 I. Then we have taken, now we took B2 hat common. So what is we can this term, these two terms can be written as B2 hat bracket open summation x1 I x2 I minus x bar 2 summation x1 I. Now the equation which we have just now got like a meaning thereby, this equation. This equation, now we are going to work with this equation. Now basically what we are trying to do, as just if you have a look at it, we are trying to write, this is the equation and we will write it in this format. We will be writing the above equation in the format of the below one. Now, so just I show you one of them. I open, like I take one term summation x summation small xi small x2. Now this is small x. Now if I open it, small xi is nothing but x1 minus x1 bar, x2 is nothing but x2 minus x2 bar. Now we do the cross multiplication. It means one term of this is first multiplied with this, then this it is multiplied with this. Similarly, next time this term is multiplied by this and then this is multiplied by this. So what we get is summation bracket open x1 x2 minus x1 x2 bar minus x1 bar x2 plus x1 bar x2 bar. So this can be now, this equation can be now written as, we are taking the summation here, the summation sign was outside the bracket, we are taking summation side inside, so it becomes summation x1 x2 minus x bar 2 summation x1 minus x bar 1 summation x2 plus n x bar 1 x bar 2. Now this next time what we do, we are writing the same thing again. Now upon this, now we open up few of the terms, we will be reducing it. So what we do, this one over here, n x bar 1 x bar 2, we are opening up in the form of x1 divided by n and x bar 2 as x2 divided by n. So now we will cancel the n terms. We will cancel the n terms. This n and this n and this n is cancelled. Now what is left is x bar n. This becomes x bar and this is summation x2. So if you see, this term and this term are the same. So this and this cancels out. So finally we can write this as summation x1 x2 minus x bar 2 summation x1. So all this is done in it's not in the deviation form, it's the normal x. Similarly, other two I am not deriving it, I am just in order to save time, what I am doing, like we have done here summation x small x1 x small x2, what we do it the same thing, the same process we repeat for summation small xi yi. Now when we do, we open up So summation small xi is nothing but xi minus x bar, and yi is nothing but yi minus y bar. So this can be finally written as summation xi yi, all capital Xi capital Yi minus y bar summation xi. It is by the same process we can you can do it on your own. Now next time we take another variable summation small xi square. Now here what we do, so xi is x minus x bar, so we can write it as summation xi minus x bar. Here we will be using the formula a minus b whole square is equal to a square plus b square minus 2ab, and upon opening the terms, and then we will cancel some of the terms. So finally what we get is this. Now if you see this term, they are the same. Similarly, we have some other, this term is the same as this one. If we now, we are simply, as we have said, that our purpose was to write this equation, and this term, and these three terms, they have been highlighted in different colors. We can write it in this format, in the deviation as such. It is coming here in the deviation format. So the final equation is, or you can say the final deviation format, we got the normal equation, that is all in small terms, summation x1i yi is equal to b1 hat summation x1 square plus b2 hat summation x1i x2i. Now, so the same thing can be repeated for the other equation, and you will get the same thing can be repeated for the other equation, and we will be getting this. That is, the next equation we will be getting, just like see, we had basically three normal equations. From the first equation we got the value of b naught hat. From the second equation we got the earlier one, we got this one, and from the third equation, upon algebraic manipulation, what we have just seen just now, we will get this equation. So the basic purpose what we have done till now is, we have got these two equations, they are termed as equation 4 and equation 5. From this we will be deriving the values of the formulas of b1 hat and b2 hat. So from these two normal equations, our purpose is, our next motive is to find the values. Like we have given here the values, what is the formula for b1 hat and what is the formula for b2 hat in a case where there are two independent variables x1 and x2. But to solve this, we need some basic knowledge of matrices. So because we will be solving this, we will be deriving the values from these two equations. We will be deriving the values using some basic operations of inverse of a matrix. We will be using the inverse of a matrix to solve these two equations to get the values of b1 hat and b2 hat. As it may be that some of you are not familiar with this, so I give you a very quick and a brief explanation of how the knowledge of matrix is being used over here. Suppose we have these two, now there are three matrices. One is the coefficient matrix A, the other one is the variable matrix, and the next one is the constant matrix. So we have, suppose, three matrices like this, Ax is equal to B. What we can do is, we can take the inverse Multiply both sides by the inverse of A to obtain the solution. So what we have done, this coefficient matrix, we have taken the inverse in the left hand side and also in the right hand side. This becomes an identity matrix. This is equal to A minus A inverse A minus A inverse matrix B. So X matrix, you can write it as finally A matrix, A inverse matrix B. So, okay, this may be, this notations A and B, it might be confusing for the first time to those who are listening to this concept, but an example will be, I think an example will better explain you. See, we are trying to solve a system of linear equations. We have the first system, first equation is 18x minus y is equal to 87, and the second equation is minus 2x plus 36y is equal to 98. So what we have here is, we are having two equations and we are having two unknowns x and y. We can write it in the format of a matrix, as we have seen the three matrix. So what we take the 18 over here, from here it is minus 1, we take minus 1 over here, minus 2 over here, and 36 over here. We have taken we have made a 2 by 2 matrix. The two variables which are unknown, they are written as like this, xy, and this, the result, that is on the right hand side values are written as like this. So now what we do, we try to find the determinant for this matrix. To find the determinant, we have, like, this is a determinant, we show it by the sign, that is A, and we put two lines on both the sides. So this is what we indicates that we are going to calculate the determinant. We do the multiplication of this with this, and next the multiplication of this with this. So now 18 multiplied by 36 minus, it will be a minus, and then minus 1 multiplied by minus 1 multiplied by minus 2. So this turns out to be 646. So the determinant of this matrix is equal to 646. Now the next thing which we are going to find is the minor. Minor means, like, see, we have this first matrix. We write the matrix again, 18 minus 1 minus 2 and 36. Now for this term, so we write it as M11 means 1 stands for row. So this is the first row and 1 stands for the first column. So M11 indicates I am talking about this one. So the minor for this can be derived by, we will strike out this row, we will strike out this column, what is left is 36. So for M11 the minor is 36. We take another example. Say we want to find the minor for this term. We want to find the minor for this term, like we have 18 minus 2, 1, 36. We want to find. Now this term is, it comes in the first row. It comes in the second row. So M second row, the first term in the subscript stands for row, and this is in the first column. So this is M21. Now for M21, what we do, we cancel the row, we cancel the column. So what is left is 1. So for M21 it is equal to 1. So sorry, M21 it is, the value is minus 1. So M21 the value is minus 1, and see, so we have like this. When if it is a 3 by 3 matrix, then it is a bit different thing, but at the moment, because we need to solve it for 2 by 2 matrix, that's what we are doing over here. So now similarly we will find the minor for this minus 1, this is equal to minus 2, and the minor for this term, this is equal to 18. So what we have done in this slide till now is, we have found the determinant, and then we have seen how to get the minor. Now we find the cofactor. Cofactor is like for the for the cofactor of the term 1 1, cofactor for the term 1 1, we take the minor 1 1 which we have just now derived and we multiply it with this. This is only the play, this is only done to manipulate the signs, and that is nothing else. Like see, so means I am quickly writing you something that what we started with 18 minus 1 minus 2 36. We started with this 18 minus 1 and it was minus 2 36. This was our first step. The second step we found the minor. Okay, let me, I have already put the mark. So the minor was 36 minus 2 minus 1 18. 36 minus 2 minus 1 18. Minus 1 18. Now we are just going to multiply. See, if it is 1 1, so 1 plus 1 2. So minus 1 multi raised to the power 2. So minus 1 multiplied by minus 1, this becomes plus 1. So 36 retains whatever sign it is having, plus. Next time the next value is minus 2. Now here this is first row and second column. This 2 stands for, this is the first row and second column. So if we do right here minus 1 multiply raised to the power 1 plus 2. So this is 3. It means minus 1 multiplied by minus 1 multiplied by minus 1. This is equal to minus 1. So what was minus 2 over here? You multiply it with minus 1. So this becomes 2. So when we are finding next time, let us see, here it is also minus 1 for this term it is also 2 plus 1 3, means this case will hold. So what happens, it was minus 1, we multiply it with minus 1, it becomes plus 1. Then the last term, is like say second row, this is coming in the second row and the second column. So when this is like this, so it becomes 2 plus 2, 2 plus 2 4. It means minus 1 multiplied by minus 1 multiplied by minus 1 multiplied by minus 1. So this turns out to be a positive plus 1. So whatever is the term, 18 multiplied by plus 1, that is equal to 18. So we had this original matrix, this was the minor thing, and for the, now we find the cofactor matrix, that is, this is my third step. Once we have done with the cofactor matrix, now we find the adjoint of the given matrix. Adjoint of the given matrix is, you transpose the rows into columns. Like see, this was 36 and 2, this I write it as 36, and the 2 which was all earlier here, now we will write the 2 here. And so this one, it will go over here, this 18 remains in the same position. So from this we get this matrix, this is the fourth step. So how do you find the adjoint of the matrix? We simply convert the rows into columns. Now A inverse is nothing but the formula is given over here. Excuse me. Inverse of A is equal to 1 upon the determinant of A. Determinant was the first thing which we had calculated, multiplied by the adjoint of A. Adjoint of A was the last thing which we have calculated. So just to you to have a look, see, we have calculated here we have calculated the determinant, and here we have calculated the adjoint. So we will use that information 1 divided by 646 and this adjoint matrix. Matrix division is is simple. Like we have this, what we do, we have this 36. So this is my matrix. I want to divide by 1 to 18. I want to divide it all by 646. So what we do, divided by 646, divided by 646, divided by 646, divided by 646. So this is what we get. Now to find the value of x, x is equal to A inverse B. Now A inverse B, A inverse is here. What is this B? B is the result column, the right hand side, if you remember. B is this matrix. This matrix. So Ax is equal to B. For that, what we do, so we just simply write it over there. Now we have this term 18 divided by 323, 1 divided by 646, 1 divided by 323, 9 divided by 323 multiplied by 86 divided by 98. When we do, we find one term is this, next term is this. So upon dividing this, we get as 5 and this we get as 3. So we can say the value of x is equal to 5 and the value of y is equal to 3. This was just a brief discussion on how to find the inverse of a matrix and how to solve a use that rule of inverse of a matrix to solve a simultaneous equation. Now, so using just the same logic, what we do, we will from these two equations, we will form the matrix in the deviation. We will find the values of B1 and B2 in the deviation format. We will take that up in the next class. Thank you for the moment.